All right, so for the people watching on YouTube Live, sorry, we started a little bit late today. We forgot the tripod in the office. People in class are right now sitting in their groups, and they're figuring out what the cost to make one of those peanuts that we made in the lab would be if they were making it in our factory that we set up last Thursday. So last Thursday we set up this factory. It cost we thought it cost about $150,000 to get the equipment that we needed to make these peanuts. And today we added in the cost of real estate. We assumed we had a 5-year lease on 1,000 square feet at $1 square foot. So it's about $60,000 rent payment just for the space where we put those machines. Now we're trying to figure out what's that actually cost to make one of the peanuts once we've got all the equipment in place. So that's what everybody's doing. We're spending about 2, 3 more minutes on that, and then we'll get back to the class. Okay. Um, at the level of automation that we discussed on Thursday, you're still going to need an operator somewhere, right? This is a math building, right? Yeah. How come the num lock was turned off on this computer keyboard? No math people like numbers. You guys ready to talk? All right. Excuse me. All right. What are the factors that you guys put in? Material cost. You had material cost. Yep, and then we had labor cost. Material cost, labor cost. Anybody have factors other than material cost, labor cost? What do you got? So, um, so operating utilities for the machine. Anybody have any other costs that they factored in? So certainly we have to have material cost, right? Because manufacturing is taking raw material and turning it into something. The raw material costs something. Does that make sense? Um, did everybody have material cost, labor cost? Did other groups have power, things like that? No. Okay. Well, it certainly costs. So that goes in there. What was your labor rate? We said $20 an hour. $20 an hour. What does that cost the company? $40. Costs the company about $40 an hour if the labor rate's $20 an hour. The general rule of thumb is whatever you pay the employee, double that. That's what your cost is. Because the company contributes to taxes, the company contributes to insurance. There's other things. What was your labor rate? We did 1750. Okay, you guys. So you guys are all going to quit and go work for them. What was your labor cost? 20. 20. 20 is a good average price for a CNC operator in this area. So 20 range from about 17 to about 30 for a CNC operator, depending on their skill set, what they do. So those are fairly good labor rates. Did anybody double it for cost? Okay. So what's the material cost per T-nut? What'd you guys get? 94 cents? What'd you guys get? You got 104. 104? What'd you guys get? $1.27. What'd you guys get in the back corner? $3. Man, you get some platinum T-nuts. All right, but our material cost is somewhere between $1 and $3, right? If we make more, what direction does the material cost go? Down, right? There's ways to get that material cheaper if you buy it in volume. Quoting it on McMaster-Carr is always a high estimate because you can always find a cheaper way if you're making them in volume. What if you're making just one? Where should you get the material? Go ahead and get it from McMaster because you don't want to have extra material left over if you're making just one, right? Did somebody say you could buy it in 1-by-1 pieces? Did I hear that? Yeah, okay. I'm sure you can, one way, we talked about getting an automated bandsaw as part of our capital equipment, right? One way that you can automate that from the standpoint of your operating cost is you could have the people that are selling you the material cut it for you. And so that's outsourcing instead of automating, right? But it's not the kind of outsourcing that we hate where we're outsourcing it to India to a call center, right? I was this bank that was horrible, and I could not get them to fix the online payment thing so that I could log on and pay my mortgage. They just couldn't fix it. And then they moved their call center to India, and the very first call I made to the guy in India, he fixed it. Best thing they ever did was move their call center from California to India because you actually got to talk to somebody who cared about doing their job. So not all outsourcing is bad. All right, material labor costs. So what's your cost per T-nut? If you double the labor, what's your cost per T-nut? You double the labor. So we have like 10 minutes per T-nut for both sides. Okay. So every 5 minutes you flip a T-nut over? Wait, no, the robot's flipping the T-nut over, right? Okay, good. Yeah, so we have like 10 minutes total.
And so 40 divided by 6, or 10 per hour would be like 6.6 dollars per unit.
Material and labor.
Oh, no, so that was a special manage. We doubled the pay rate.
Yeah, well, your cost is going to be double whatever you put in the equation.
We didn't do double though.
So what's your cost per T-nut?
It would be 354.
354 per T-nut? What do you guys get? Anybody get less than 354? What do you guys get? About $6. So you guys are about $6. They were about $6. What do you guys get back in the back? $7. So you guys are efficient. Why is yours less? Oh, you're gonna crank up the feed. All right. Nobody remembers how long the T-nuts cost. Take.
I got off time on was like 8 minutes total.
Okay, but you could optimize that somehow, right? Okay, so you might get it to 5 minutes.
You have a robot.
You have a robot doing it. Okay, so we might get it to 5 minutes. $3 a T-nut. How much do they sell for? $4. So somebody's making them for less than $2 if they sell for $4 at retail. How do they make them for less than $2 if you guys came up with 3 and you guys came up with 7? Yeah.
We had thought if you had made multiple at the same time, that would cost.
How does that cut down? So okay, I like it. You're gonna set up a fixture that makes like 6 of them at the same time. Okay, how does that cut the cost down?
Well, cut down the time it takes to get one.
So okay, so how does it cut down? So I agree. I just wanted somebody to say the mechanism how it cuts down the average time.
So like take longer, but you have more T-nuts per day.
The program runs for a longer amount of time, each program, but it does fewer tool changes. And so you've got more time adding value to the part if you're doing fewer tool changes, right? So setting it up where it makes 8 in a row down the thing, where your tool goes this way because you make that little shelf thing, and then drill all the holes, and then thread mill all the holes or tap all the holes. Maybe you can find a process that's faster than the thread milling that we did to make those holes. Okay, so you can speed that up. When the machine is working, what's your operator doing? Because I said we had to have an operator, right? Somewhere here we got to have an operator. Do we need the operator for the full 10 minutes? When do we need the operator?
Yeah.
We need the operator to load the bandsaw, right? Because we got a CNC bandsaw. So we need the operator to unload the truck, load the bandsaw. We need that. Do we need the operator at the shipping end? Maybe. But if the process is automated, could that operator be doing something else that's valuable for the company? If they are, how much of their time do we attribute to the T-nut? Now, you put in labor and material cost, right? We didn't consider this cost. How do we factor that cost in? So your charge rate was $20 an hour, right? Everybody's was around $20 an hour. How do you factor in the cost of all that capital equipment we just bought? And understanding the cost of making a T-nut? Because all of that is dedicated to making these T-nuts, right? So how do we factor that in? What's the life of one of, yeah?
What is that? So cut into whatever profit you make off these T-nuts?
So, well, you want to make back that capital to give it to somebody else. But the company has the capital, and it is invested in these machines, and over time they wear out, right? So at some point in time, we're going to have to replace them. So we could, so our 5-year lease at $60,000, we said that's $1,000 a month, right? That's how we got to that number. So if I got, so how much does your employee cost per month? $40 an hour, 40 hours a week, 4 weeks. So I'm going to show you a different way to calculate it. So our employee costs us $6,400, and that's with full benefits, right, or whatever we're giving them. So our employee is $6,400 per month. So I went online. I went to a I went to an online equipment lease calculator. I put in some numbers here, and so it turns out that $150,000 worth of equipment, we don't have to buy it. We can lease it. If we lease it, we're going to be paying about $2,000 a month. You guys wanted to pay the power bill, right? Turns out you can let that slide for like 3-4 months before they shut it off, you know. So, but you guys want to pay the power bill. Any guess on how much power it'll cost? How much power it'll cost to run this cell that we envisioned? So we got a CNC bandsaw, we got a mini mill. I'm just looking for a guess. So I run a room full of machine tools. It's about $600 a month, and we've got normally 5 to 12 spindles running 5 to 10 hours a day. That's a lot more power than we're going to need here. So let's say we're going to use a third of it. So let's say it's $200 a month for power, and that's just a guess. But $200 a month for power. Now our lease, did we put that in there? We got $1,000 a month for our lease. So now what are we at month here? So 60, so 3, 9, so $10,000 a month. So it costs us $10,000 a month to keep the doors open. How much does the T-nut sell for? How much do we have to sell them for? We have to sell them for $2, right? In order to be able to resell them at 4, we got to sell them for 2. So how many T-nuts do I have to sell at $2 to get to 10,000? I had to sell 5,000 T-nuts. So if I'm going to sell 5,000 T-nuts, how fast do I have to make them? That's a month, right? So 168 hours a week times 4. That's how many hours we have total. You're not going to run 24 hours a day, 7 days a week. You have fewer hours than that. At some point, you're going to have to do maintenance. How many T-nuts? So I got to sell 5,000 T-nuts. Can I make 5,000 in a month with this cell? How many hours do we have to operate in a month? 672 hours in a month. And so divide that by 4. Well, if we're going to make 5,000 T-nuts in a month, how many hours do we have to operate? We're making how many T-nuts an hour do we make? You guys are making a T-nut every 5 minutes. So you make how many an hour? 10. 12? So let's call it 10. Okay, so we're making 10 an hour. 5,000 divided by 10? 500. So I get 500 hours. That's 120 something hours a week, right? So 120 hours a week is like 40 hours a shift. So that's 3 shifts. So if we run 3 40-hour shifts, we should be able to make 5,000 T-nuts, right? So then maybe it is possible for us to sell those at $2 a T-nut. So there's 2 different ways to calculate it, right? And so what you want to do is figure out how do you, and so you guys, have I given you guys a haiku yet? Maybe I've even given you this one. Engineering's math, just a bunch of word problems, cancel the units. And so what's the trick with solving a word problem? From back in 5th grade. What's the trick to solving a word problem? You got to understand the question, right? If you can understand the question, especially you guys are all good at math, pretty much. You ever sit around the table at the restaurant with a group of people, and the waitress is like, "Do I need to split up the bill?" And just look at her and say, "No, we're good at math." We used to do that all the time. So the trick is to understand how to formulate the problem. And so if we break the problem down by monthly operating expenses here, now, is this all of our monthly operating expenses? No. What else goes in there?
I feel like there's at least one like janitor there. cleaning up the shop.
You'd like to feel like that. When I when I started my first company that had employees, I would have liked there to be a janitor too. And I had done a lot of online training about entrepreneurship before I started this. I wanted to know what I was getting into, and I printed these really cool glossy business cards. Chief Executive Officer, it said right under my name there. And I did the online CEO training. I was in the mastermind groups, and you know what? None of them ever talked about when they were selling that training. Broom operation, emptying trash, moving pallet jacks. But you're right. So there is a janitor, and he wants to get paid. And so when it's a startup and it's a 1 or a 2 person company, you're the janitor, right? But you want to get paid, right? How much do I want to get paid? I want to get paid a lot, right? You don't start a company because you don't want to get paid a lot. Start a company because you want to get paid a lot, right? You want to show up in your fancy car every day. So how do we make more money? I think we need to ship a more expensive product. I'm not sure this is the product, unless we get the cost down a little bit. But so what I want to do is wrap our arms around the cost to make the part. So it is possible here to do this. And so if we were dropping this cell into an existing factory, then there's a way to get some profit out of this, right? We got to get the cost down just a little bit from where it is in order to get some profit out of this. I had never figured out the T-nut thing before. I didn't know which way it was going to come out when we figured it out here. So, all right, so we can do this. We can figure out how much it costs to make a part. Who's ever bought a machined part? You have? Or no, like bought something from a machine shop. So had somebody custom machine something for you, send them a design, got the part back. No, some people have you?
We didn't necessarily buy it like high school robotics. Get on the team, dad owned a machine shop, so we just sent them stuff.
Yeah, and then they sent it back, but they didn't charge you for it, right? Um, so it's going to cost us about $2 to make these T-nuts. Is that what we figured out? If we're making them in volume. Let's take another 5 minutes and sit with your group again, figure out how much it costs to make the first one. So when all of this, we discounted the engineering cost, right? We did not include any engineering costs in all of our calculations here, right? And I told you to do that on purpose when we started this exercise. I said, forget about the engineering. The design is already done. We've already figured out the program. We've already got all that done. But to make that first one, or to change the fixturing setup and make 6 or 8 in a row, we've got to now do some engineering work. So it costs $2 to make a T-nut if we're making them in volume. How much does it cost to make one T-nut if you don't already make T-nuts, but you have the equipment? So it's going to include the $2 that it costs us. It's going to include that because we still have to do that step. How much does it cost to figure out that step? Like 3 minutes. Just sit with your group, talk about it. How do you guess that cost?
No, you said we already have we have like all the stuff that you make it.
Now you already own the factory. You work at the factory.
We have
Um,
engineering or we
Well, you're an engineer, right? If you own the company, it could be the two of you guys.
so do we already have like
One of you guys. I don't know. Do you? So you're gonna have. So Well, no, but you gotta. So how do you charge for that though? Because you have to charge your customers for that. That's what I want. So that is the right question. So he asked over here. Vince asked, "Do we already have the software licenses?" I said, "Well, you have access to the software, but how do you charge the customer for the fact that you bought that software?" Right here, we figured out our monthly costs, how many parts we could make in that month, and that's how we figured out what we could charge, what we could sell the parts for. So so anybody know what a SolidWorks license cost? You guys gonna use SolidWorks? Anybody? If you're gonna use SolidWorks in this process, SolidWorks license costs, I don't know, between $5,000 and $15,000. And then there's an annual maintenance fee. I don't remember what it is. Yeah, you guys gonna use a Spree? Anybody know how much an Esprit license costs? The ones we have on the computers over here, $35,000 a pop. Each seat. Esprit is not cheap software. So you've got to consider that in your cost of engineering, because you had to pay for it. What else do you have to have an engineer? You got to have a computer, right? So how much does it cost to operate a computer with those licenses? So for the year. So without even paying for the engineer, you've got to pay, I don't know, $15,000. Let's say we use it for 3 years before we have to pay another $15,000. It's $5,000 a year just to have the software. How much does the computer cost? $3,000. Good high-end workstation. Well, you want a nice computer. You're doing SolidWorks and CAM and stuff, right? Yeah, but you gotta have a number. So how long did it take you guys to write how long would it take to write the program for this? All right. How long does it take to make the program to make this T-nut? You get the drawing for the T-nut. Yeah. Took you like 2 days, right? Yeah. That's why you need to be the owner of the company, because you don't get paid until the company's profitable. But how long do you think it should take if you have experience doing this to make this program? 10 minutes, 20 minutes? I'd say 20 minutes, because you gotta look at the print, you gotta look at the things. If all you got was a print, then you gotta draw the model, perhaps, right? So I'd say 20 minutes. So what do engineers get paid? More than $20 an hour, right? What are we gonna pay our engineers? $40 an hour. All right, that's fair. So we got to double that, $80 an hour. 20 minutes. How much did it cost just to make the program? So $80 an hour, 20 minutes. Cost $30 to make the program. How long does it take to set up the machine? Make the first one? 20 minutes to set up the machine? Who's setting up the machine? It's not that $20 an hour guy. It's maybe a $30 or $40 an hour guy. Maybe the $20 an hour guy is doing it. So if he's doing it, set up the machine, $20 an hour, 20 minutes, that's $5. So we're $40 into the first T-nut now. So it's going to cost $40, $50 to make the first T-nut. It costs $2 to make the second T-nut. How do we make that $40 go away? So yeah, so if you got an order for 10,000 T-nuts, that initial engineering stuff gets lost in the noise, right? You just absorb it. But if you're making prototype parts, you can't just absorb it, right? That is what you're selling, is that engineering time. How do you make that go down?
Does this happen over time when you're like?
Well, so yeah, over time, as you do it more and more, you get better and faster at it. But we made the assumption that we were good at it already. It still takes finite amount of time. Load the file in the computer, get in front of the computer, say, all right, we got these tools, we're going to use these tools, right? How do we get that time down? Is it possible to make that time 0? Right, well, that's the title of today's lecture, right? We want to get that, because that first part is really expensive. Second part's cheap. Second part costs us $2. first part cost us $50. If we're going to make 10,000, we don't care that we spent $50 on the first one. But if we're going to make one, we have to care about the $50. So we can do automation at that end of the company also. So a factory style company, right, where we're doing the same production parts over and over and over again, that's where you're going to do this kind of automation where you automate the flipping the parts over in the machine tool. You automate the bandsaw cutting. You automate the transportation from the bandsaw to the machine tool, right? Because there's ways to do all that. But you're going to do that typically where you have high volume production. It's difficult to do that kind of automation where you're always changing the part, right? We're going to make 3 of these, 5 of these, 6 of those, and 8 of these today. And that kind of workflow happens in these smaller job shops. But the job shops can still automate. But what they've got to start with is automating that upfront cost of, so if your customer wants you to make these T-nuts, and they've asked you, how much is it going to cost to make the T-nut, 5 of these T-nuts? And I have machined special T-nuts for people before. It's a thing that happens. It's not that shape. Those they can just go buy from McMaster. They get a special metric thread or something like that. We've brought in jobs. We've done T-nut machining before. We had to charge them, Jesus. We were charging $27 a piece, these little tiny T-nuts. But they were about this big. Part of the problem with them was they were about this big. They had a 440 thread through the center of it, and made out of titanium. Right? They had this special requirements for their T-nuts. So what you want to be able to do is eliminate that upfront cost, which brings me to labs this week. Hey, Ryan, do you have anything you want to say about the labs this week?
No, we'll have to see it tomorrow.
All right, Ryan's going to talk to you about this tomorrow. What we're talking about this week is how do we leverage the $35,000 value of that Esprit license? Because if all you're going to do is sit there in front of it and make these one-off little 2-axis milling programs, you don't need $35,000 CAM software. In fact, we know we could write that program in G-code, right? You could have written the program for that T-nut in G-code. So how do we leverage that valuable software? And it's by doing things like, so in Esprit, we can build a tool library. And we can have Esprit know what tools that we have in stock. We can, in fact, build, there's a plugin. We can have Esprit automatically order new tools for us when we start getting low in stock for a certain kind of tool. And it can automatically talk to our vendor that sells us the tooling. That feature is not turned on at WPI because we don't want you guys making us bankrupt, right? but you can do that. And so we're going to talk about how do you have a tool list? How do you have Esprit automatically recognize the features? So you can literally drag and drop the file onto your dialog window, click the go button, and have it send the code to the machine tool, and you didn't have to do anything as the engineer. Except you had to do all of the programming to tell Esprit how to do that. Because you got to tell it what machines you have, you got to tell it what tools you have, you got to tell it what parameters you want to use, things like that. And so that's what we're going to do for the next 2 weeks in lab, right? For the next 2 weeks in lab, you'll be going through some exercises in Esprit to learn how to use the automation features that it has so that you can have it automatically create the code, send it to the machine tool. And this is stuff that we've done at WPI. You guys ever come around for any of the summer functions? No? Like Touch Tomorrow, Alumni Weekend, any of those things? So one of the things we do with Alumni Weekend is we give them a little keychain or medallion or something that's got the WPI seal on the front of it. And the alumni get to come back to the shop and engrave their name on the back. And so they literally come into the front of the shop, type what they want in a dialog box in the computer window. They look at it, they get a simulation of it. They say, okay. They walk to the back of the shop, and that code is already running on one of the machines. So you guys can do this kind of thing and implement it. So that's what we're going to do this week in lab. We're going to figure out how to work ourselves out of a job. But if you're the guy that created this system, you're valuable to the company. Don't worry about it. I know the CEO of Esprit, and his goal for the company is to make the software nothing more than a printer driver. He wants the operation of part to machine tool to be drag and drop. And they've designed the software so that you can get it at that direction. So he's trying to eliminate all the engineers, except for the ones that work for him. All right, thank you for today. What are we doing? So lab tomorrow. Thursday, we are going to, Thursday, it's good to be in class rather than watching online. Thursday this week, we're going to go through a case study. We're going to start that, and finishing that case study is going to be the homework assignment. But we are going to talk about a factory automation problem which came up that I did some work on, and we're going to use the actual parts there and their requirements. So when you come in on Thursday, be thinking about what you would ask the business owner that called you in to automate their production problem. All you know now is that they have a business, they have some production step that they want to automate. So be thinking about what questions you want to ask when you get to that initial interview with the company. All right, see you guys tomorrow and Thursday. It's the most powerful camp software ever because it says so right on the splash screen when you log in.
Exactly. That's why I was
That automatically order tools thing, that scares me. You could actually have it tied into the Kennametal database, and it would just search through the thing and find you the tool that you need.
That'd be a great spot for a bug, and all of a sudden orders you $10,000.
Oh, wait, no.
Oh, yeah.